Alright, so today let's crack one of the most famous greedy algorithm problems, the fractional knapsack problem, right? So here you're given two arrays, val, right, which basically has the values for each of the item and wt for their respective weights, right? And also given is a capacity w of the entire knapsack, right? And our goal is basically to maximize the total value we can put in the bag, right, which is the knapsack, right? But here is a twist. You can even take fractions of an item if needed, right? So let's try to understand this and see how can we approach it using this particular example over here, right? So the input value is this, right? So this is my value array, which has the value of each of the item, and this is their respective weights, right? And the total capacity of the knapsack is 50, right? So now if you see over here, the capacity of the knapsack we are saying is 50, right? Whereas the total weight of the individual items, if you see over here, is 10 plus 20 plus 30, which is 60, right? So obviously we can't take all the items full into the knapsack, right? But we want to choose the items in such a way that the total value being taken in the knapsack is actually maximum, right? So I hope you understood that. So if you see this particular example, if I take the first and the second item in full, right, the total value will become 60 plus 100, which is 160, right? And now the remaining capacity in the knapsack would be 20. How? Because the weight of the first and the second item is 10 plus 20, which is 30. So if I subtract 30 from the total capacity, which is 50, I will be left with 20, right? So now I have the capacity of 20 left in the knapsack, but the weight of the third item, if you see over here, is 30, right? So obviously I can't take it in full, right? And I will have to take a fraction of it, right? Which will fit into the weight 20, and that will be essentially 20 divided by 30 into 120, right? So because 20 is the remaining capacity, right, divided by the capacity of this particular item, so that will be the fraction which I will be multiplying with the total value, right? So that much value is what I can actually fit into the knapsack along with the first and the second item if I took both of them in full, right? The first and the second item, right? So this particular value, when I divide it by 30 and multiply it by 20, it will come out to be 80, right? So now if I just add 80 to 160, right, I will get 240, and this 240 will be the value which I can actually put in my knapsack, right? Now we can try other combinations as well. For example, we can take item 1 and item 3 in full and take second item partially, right? But you will see that the maximum value that you would get out of all the combinations possible would actually be 240 itself, right? And so now my final output would be 240, right? That's what my expected output is. So this is the entire problem. Now maybe you can just try to think of a solution, and once you're done, you can just come back and check the solution here. Okay, so now here basically we need to maximize the value that can actually fit into a knapsack within its weight capacity, right? Hence, our objective is basically to have maximum value but the minimum weight, so that I can essentially fit as much value as possible in the knapsack within its weight capacity, right? So for this reason, I can actually calculate the value per unit weight of each item and then start by selecting the items with maximum value per unit weight, right? Right? Because the value of that particular item per unit weight is actually maximum, right? In minimum weight, I'm getting maximum value, right? Hence, I would be selecting that particular item first, and I will try to fit that item first in the knapsack, right? Because that will be giving me maximum value in minimum weight again, right? So I will essentially be looping over all the items, right, in my input, which are sorted by their value per unit weight in descending order, right? I can just maybe take the weight array, take the value array, combine them, right? I can make a pair array, and each pair will be having the value and the weight of the respective item. And now I can basically sort this particular array based on their value per unit weight, that is value divided by weight, right? I can sort it by this particular key, and now what I can do is I can loop over this particular sorted array, and for each item I will just check if I can actually fit this particular item in full in my knapsack, right? And if I cannot basically fit it fully, I can actually try to fit a fraction of it, right? So that's what I will be doing entirely, right? So for each item, if it fits completely in the remaining capacity of the knapsack, we will take it. If it doesn't fit, then we take the fraction of it that fits, right? And finally, we stop when the capacity is fully utilized, right? So that's what we will be doing. Now we can just quickly see the algorithm steps of this particular solution. So first of all, as we discussed, we will be calculating the value to weight ratio for each of the item, right? Then we will be sorting the items in descending order of this particular ratio, right? Then we will iterate over each of these items in the sorted array. And if the current item fits completely in the knapsack, right? That is the total weight of that particular item is basically lesser than or equal to the remaining capacity of the knapsack, we take it completely, right? Otherwise, we just take the fraction that fits into the remaining capacity, right? And we will stop when the capacity of the knapsack has become zero, right? The remaining capacity of the knapsack has become zero and the knapsack is full, right? So that is the simple greedy algorithm that we can follow over here, right? So let's actually walk through this with an example for better clarity. So taking the same example again, the values of our items are 60, 100 and 120 and the respective weights are 10, 20 and 30, right? Now first we actually calculate the value divided by weight ratios for each of these items, right? So if you see over here, if I divide 60 by 10, I will get 6. So the value by weight ratio of item 1 would be 6. For item 2, it would be 100 divided by 20, which is 5. And for item 3, it would be 120 divided by 30, which is 4, right? So the value by weight ratio of this particular item is 6. For this, it is 5. For this, it is 4. And as you can see, this is the highest value by weight ratio item, right? So I will be considering this first, right? Basically, I will be sorting this particular entire items array based on the value by weight ratio, right? But since over here we are getting, all the items already sorted by their value by weight ratio, we are good, right? Now what we do is we begin with the item with ratio 6, right? And its weight is 10, right? And the remaining capacity is 50 itself because we haven't put anything in the empty knapsack as of now, right? So we can just pick it fully and now the remaining capacity is 40, right? Because 10 we have utilized for this particular item and now we are just left with 40, right? Next we pick the item with ratio 5, right? Its weight is 20. So we can again pick it fully because 20 is lesser than the remaining capacity, which is 40. So we can pick it fully and now the capacity which will be left will be 20, right? Like this. Now what we do is we move to the third item, right? Over here, the total weight is 30, but the remaining capacity is 20. So we can only take 20 by 30 of it, right? Which is 0.67, the fractional value. Only that much we can take of this particular overall value, right? Which will be actually 80, right? So now the total value that we have got is actually 80 plus 100 plus 60, which is 240, right? And so my maximum value is 240, right? So that's the entire algorithm. That's what we need to do. And that's the optimal solution for this particular problem, right? Now this greedy approach always works for the fractional knapsack problem because taking the highest value per unit weight will always give me the optimal result, right? Now talking about the space and the time complexity of this problem, since we need to sort the items in descending order first and then loop over them, the time complexity of this particular solution will be order of n log n overall, right? And before actually sorting, we will have to first create a new array in which we will have the pair of value and weight for the respective items together, right? And so the space complexity would be order of n, right? So that's the time and the space complexity. And now let's code this particular solution. All right. So to start with, I will just declare a function called fractional knapsack, maybe like this. And this will accept the value array, right? VAL, the weights array, right? And also the capacity of the knapsack, right? Now what I will do is I will just capture the length of the total items that are there in the input in this variable n, like this, right? And now what I will do is I will just declare that pair array that we were talking about, right? Wherein we will have, the pair of every value with their corresponding weight in a single array, right? So for that, I will just use a list comprehension over here and I will do for I in range n, right? Which is the total number of items. What I will be doing is I will be creating a pair using weight of I, right, comma val of I, right. This way I will be pairing each value with its corresponding weight, right. That's what I'm doing over here. And then what I will do is I will just sort this particular pair array in place, right, using the sort function like this. And over here I will be sorting in descending order, so I will essentially give the reverse parameter as true like this, and the key will be based on the ratio, right. So it will be using a lambda function over here, and I can say lambda x, and I will be selecting the first index divided by the second index of the current item, right. Because if you see, the first index is essentially the value of the item, and the 0th index is essentially the weight. So I'm doing value by weight for every item, and then that's how I'm sorting, right. That's the key for the sorting. And now what I will do is I will just declare my result variable over here, res, and I will initialize it to 0, right. And also I will just declare a capacity, like a cap variable over here, which will be initialized to the initial capacity of the knapsack. And with every item that I'm including in the knapsack in every iteration, I will just keep reducing the capacity over here, the remaining capacity. So this is basically the remaining capacity, CAP, right? And now what I will do is I will just loop over every item of this particular sorted pair array like this, right? And now what I will check is if my per unit I of 0, right, that is the current item in the per unit array, the weight of it is actually lesser than equal to the remaining capacity, right, of the knapsack. If that's the case, what I will do is I will take this particular item in full, right. So I will just increment my result variable by the total capacity, the total value of this particular current item, right, which will be given by I and 1 like this, right. And then finally I will be deducting the weight of this particular item, current item, from my remaining capacity, right, like this. It will be given by I of 0, right. So this will give me the weight of the current item, which I will be deducting from my remaining capacity, and this will be my new remaining capacity now for the next item. And I will be adding the value of the current item in my result, right, because I'm taking this in full, right. And now if that's not the case, like if the current weight of the current item is not less than equal to the remaining capacity of the knapsack, it is actually greater than the capacity, then I have to take a fraction of this current item, right. So in that case, what I'll do is in the else, I will just do res plus equal to cap, the remaining capacity multiplied by per unit I of 1, right, which is basically the value of the current item, right. And this I need to divide by the weight of the current item, right, like this and like this, right. And finally I will just reassign 0 to my remaining capacity, because whatever I was left with, right, I have utilized it in incorporating this current item, right. So that's why my remaining capacity would be 0 now, right. And finally, after doing everything, I will just check if my remaining capacity is equal to 0, then I just need to break. I don't need to iterate further, right, because I have exhausted the entire capacity of the knapsack, right. And this is where I need to break. And finally, my result variable will have the maximum value which is possible to be placed inside the knapsack within the given capacity. So I will just return the final result variable, right. So this is the entire solution, and now I will see you in the next one. Thank you.